Oh baby. Alright. So the tip I'm going to give you guys to start these things is to pick the bottom corner. I like to start right here. This is where I like to start typically on most of these isometric sketches. Okay? And I'm going to work on one side or one surface at a time, and I'm going to complete that entire surface. Okay, so one tip I can give you is to take a marker or a highlighter or a colored pencil and just kind of follow on your isometric sketch what you have drawn. Okay, so we're going to draw this line right here first. Okay? How many degrees off the horizon did I say to draw the axes? Do you guys remember? Huh? Yeah, 30. Okay? Gotta make sure you guys can see this. And I gotta make sure I give myself enough room. Okay. So I'm gonna start right here, and I'm gonna draw it roughly 30 degrees off the horizon. Notice how I'm taking these small strokes?
No.
Thanks for telling me. Okay. Gotta move that. This is kind of hard with this thing. Alright. The good thing about a pencil is if you get off track here, you can erase it. Okay? So I've drawn that so far. Blue line, right? Okay? You see that? Yep. Alright, now we're going to draw this line up. Now you got to start talking proportion here. So roughly compare those two lines that I have highlighted in blue there as far as their length. Is this line here half the size of this line? A quarter of the size? What do you think? About a quarter? Okay. Now again, this doesn't have to be perfect, but you're not using a ruler, but you should be able to estimate proportion. Okay? And slow me down if I'm going too fast. Okay, now I'm going to draw this line here. Now remember we talked about height, width, and depth? You have those three axes, right? Which one is this here? Height, width, or depth? That's a height line, right? Didn't I just draw a height line? Right here, right? Okay. So what is true? What are the geometric characteristics of those two lines? They have to be what to each other? They have to be parallel. So once you have the one on there, let's keep this line here parallel. Now compare those two line lengths. The two that we're doing. You saw the two we were doing, or do I have to put it back up here? How much is that? Is this one that we're going to draw right here longer, shorter, what?
Shorter.
How much shorter? About half. Good. Okay, now what I'm doing is I'm keeping my eyes on this line here as I draw this line, and that's going to help me keep the line I'm drawing parallel to this line. Okay? Matt, you can grab a chair in the back if you want. Okay, now let's draw this line here. What dimension is that? What axis is that one on? Depth? Yep, so depth, width, or height? What? Depth? Anybody disagree with Matt? Raise your hand and disagree with Matt. Yeah. Huh? Nobody? Nobody does? Huh? Everybody thinks that's depth? What do you think? Kelly, what do you think? You said depth? Somebody disagree. You know it's not height because we just said which one height was. And I'm telling you to disagree, so what's left? Width. This is a depth, right? Remember, think about the cabinet, how far away from the wall. The wall would be back here, and that's depth. Okay? So we have to keep this line here parallel to this line because they're both on the width axis. Okay? So now we can start, watch this line here. Notice how I'm taking kind of strokes here. I'm not putting my pencil down and drawing one line. And I got to stop short of that back line. So now we have all the blue lines done. This line is again which dimension or which axis is that on? Height, width, or depth? Height. Okay. Keep that parallel to the other height lines. Now this is where people get into trouble because they end up going like this. And if you guys can't see that up there, call me out again like you did because it's hard for me to tell. This is where people get into trouble. They'll go like this. Okay, and they'll make these two lines even up top, and then they think that they have to go like this. What's wrong with that? What's wrong with this line if I compared it to these two lines? It's horizontal, right? And what does it have to be compared to these two? Angled and parallel. So I need to go from back here and keep it parallel to these. I should have done a time lapse actually. I don't want to sound like a chipmunk, wouldn't I? I don't know if it records audio or not. We'll find out. Alright. Everybody good so far? Any questions? Okay, so we are right here. That's done, right? So you might use this trick where you outline what it is that you're transferring to your paper. Okay. The other thing you can do is either shade, or if you have markers, or if you have colored pencils, you can start to color in the sections that you complete. Okay? Now, here's a tricky part on this one. If I'm looking at this standing right here, looking this direction, what do you think that section looks like? You think it looks like a slant? Now your eyes are pretty powerful things, but if you looked at that straight on, can you tell that it slants away from you at all? No. You can, because your eyes are powerful and light is reflecting and it tells you that it is. But if you were to draw it, what would it look like?
Not like that.
You're exactly right. It'd be smaller. In what shape? What shape do you see here? It's a rectangle. Okay, so this one gets kind of tricky. But if I look at this straight on, what axis or what dimension do we say is this way? Depth. Do you see how this slant starts in the front of this thing, but when it ends deeper? Well, you can't see depth from the front view. You can see what two dimensions? Width and height. Okay? So this guy, it's kind of like flying over a mountain. Can you see how tall a mountain is when you're flying right over top of it? No, you can't see height from above. Same kind of idea. You can't see depth from right in front. Alright? So this thing here, even though it's slanted away, it's simply going to look like a rectangle. Okay, so it's going to look like this, and as Cadence said, it's going to look shorter. Okay, so that's kind of tricky. So right here, whoops, I got to show you. See how it says this is 1, whatever that is. They don't identify units right here. Oh, right here. All dimensions are in inches. So this is 1 inch. Okay, from here to the top of it. All right. So to get your proportion, how thick is this? See it back here? 0.75. Okay. So my question is this rectangle going to be bigger or smaller than this section that we already have drawn? It's 1 inch from here to the top, whereas this is 0.75. So is this going to be longer or shorter than this? See this dimension right here, guys?
Yeah.
That's what? 1. See this dimension right here? Okay, which is bigger? 1. So is this going to be look taller? When I draw this rectangle standing up, is it going to be taller or shorter than this section? Taller. 1's bigger than 0.75. Okay? So this right here, this line right here, has to be a little bit bigger than this line. This line should be about 0.75, and this line, or this rectangle, should be 1. Thank you. So I'm just drawing a rectangle. Now this has to be parallel to this. That's again where people get into trouble. They draw it straight across. When you're drawing isometrics, you might have a horizontal line, but typically you're going to have these lines at an angle. Okay, that is tricky. This part right here is visible from the front. What other view is this slant going to be visible from? That's a tough question. Is this slant? Am I going to be able to see this blue section from the right side or the top? Huh? From the top. If I'm looking down, I'm going to be able to see this slant. Okay? So that's kind of tricky on this shape. Anything else that if I stand right here, see how I colored the visible front surfaces blue? Is there anything else from the front that I can see based on what I have drawn right now? In other words, any other sections that I should color blue because they're on the front side? What do you think? No? See this? Isn't that on the same plane? Isn't that orientation the same? Those planes would be parallel, right? Everybody agree with that? Those planes would be parallel to each other? Okay? The problem is the plane on that back one that we haven't done yet is pushed back. Okay? So we're going to hold off on this one right now just because we haven't done anything over here. Okay? I like to work section by section. So now that we have this part done, let's start working on this section right here. Okay? So what axis is this, or what dimension is this? Show me you've been paying attention. We talked about it. What dimension is this? Depth. Okay? So do you see the dimension that tells us how long that is? Can you see it up there or not? Anybody make that out? It's hard to tell. Yeah, it's 0.50, right? Remember this was 0.75, so this has to be a little bit shorter than the height of this line. Okay? Now just like we went 30 degrees off the horizon here, we got to go 30 degrees off the horizon for our depth too. So about like that. Okay? Now see how we have this end point out here kind of floating? It's not attached to anything. That's where I like to go next. Okay? So here's our 3D pictorial. This line has to be parallel to what axes? Height, width, or depth? Height. Okay? So draw this line parallel to this line here. And then what do I have to do now? What do I have to do next? Dana, what do I have to do next? Yep, just have to connect them. And this line has to be parallel to what line? The depth. Good. Okay? Boom. Okay? So now I have this guy closed off. Oops, I should have a different color. Orange. Got that part done. Can you tell that's orange? Actually, it's red. Rojo. Rojo. Alright. Now this can be kind of tricky because I have this big space here we talked about a second ago. So let's start working on this part right here. Okay? What color should I get? Pink? I told you, yeah, pink's my favorite color. Alright, so we're going to draw this line. This line is on what axis? Width. Good. Okay, so it has to be parallel to my width lines. Okay? I have to figure out roughly how long this thing is. It's 1.5. See it right there? Okay? So it's 1.5. So if I were to compare this length right there to this length, is it quite half of that? Do you think this line is about half of that or a little bit less? I think it's a little bit less too. So let's keep it parallel. See, and I'm drawing these lines light, and then I can go back, if I get it right, I can go back and darken them in a little bit. Okay. This line here, what axis? Okay, depth. Alright. I got to keep it parallel to my depth lines, so I'm going to compare it to these two. I'm watching those two lines to make sure it stays parallel. And that was 2, so this line should be a 1/2 inch longer than this line here. Stop me if I'm getting ahead of you too far. I should have had you guys. I should have had you bring this, shouldn't I? That would have helped, wouldn't it? Oh, I see that. I'll leave this up here for a second then. Okay, let's draw this one here. That's what axis? Width. Okay, so keep it parallel to this one. Keep it parallel to this one. Alright, this one is on our depth. Okay, keep that one parallel to these. Draw this one all the way back. Now the one thing that the isometric paper, I feel like it somewhat handicaps you because you have the lines to follow, and it's totally okay, don't get me wrong, it's totally okay, you're using it, but when you're doing it, when I keep saying that it's got to be parallel to these other lines, I want you to notice these other lines that it has to be parallel to. That's why that stuff's pretty easy to use, because they already have the parallel lines there for you. Alright, now you just got to connect this corner to this corner here. Okay, so that's where we're at, right? Does that look like yours? I've got, this line gets a little janky here, so I'm going to erase it and try to do better. Am I missing anything that you guys have? Alright, let's go back to the right side view of this thing And let's just finish this one right here. Now, this one can be kind of tricky, but what you can do is, if you were to continue this line out, it should be collinear, huh? Collinear. You've heard that term before, right? It should be collinear on the same line. Keep these parallel to your heights. I'm going to continue this out. These are called construction lines, these right here. Okay? They're lines that are there to help you sketch this thing, but not necessarily part of your object. And it's okay. I actually like to see those on your paper. Just make sure that they're lighter than your object lines, which are these. Okay, everybody good? Let's finish this so that we can see that that's got some dimension to it. So that's red again. So let's go from this bottom corner and draw this line right here. You see it's starting to take shape? And one of the tricks I'm giving you that I haven't focused on yet, that I haven't stressed yet, is try to stay on one surface at a time. We just completed this entire top part right here. We closed it off before we moved on. Then we went to this right side and finished that section. Okay? A lot of people will get lost if they have a bunch of empty lines hanging out there that don't have anything connecting to it. So let's go here. And if you notice, they've got these hidden lines. These are called hidden lines, or the dashed lines there. I don't want you guys to put those there. I think it confuses you a little bit more. And then we can show this back corner right there. So you just added these three lines here. Is it starting to come a little easier? Crickets. Is it starting to come a little easier? Okay. Alright, we're almost done with this. Now where would I see this surface right here? Do I have to stand in front of this shape, to the right of it, or above it? Anywhere? If this surface were colored red, would I be able to see that it's red if I stand here? Nope. How about if I stood above it? How about if I stood to the right of it? Yes. Okay? Alright. So let's go start on this back corner that you guys have hanging out over here. Draw it up, height. Keep it parallel to the heights, so that's straight vertical. And you have three more lines to finish. 1, 2, 3. I'm gonna leave that other part pink because why take the time? You can see it. It's white right now. Let's just leave it white. So the top is white, the right is red, and the front is blue. How'd you do? Now don't worry about necessarily whether or not it looks like it's losing air. I always say that it looks like it's losing air. Oh, I didn't stress something, did I? What did I miss? What did we goof up on? Okay, so we got to put that circle in there. Is there anything else we goofed up on? The slope. Because I was stressing that the slope, if you drew it from the front, it would look like a rectangle. Okay, this line is important. Okay, this line is important. You see right here it says this line is 2. So what we have to do is we have to eyeball where you think roughly 2 is. Okay, and then we're going to put a line just like this. Then what do? Then you just have to connect that point to that point, that point to that point, and then you can erase this. Anybody remember for 5 brownie points, does anybody remember what I called these line types? Well, okay, they're parallel to each other, yeah, but there was a specific name for them. For these line types right here. Are they parallel to any of the axes that we've already drawn? Are they on an isometric line? Are they on, you guys that have the isometric graph paper, are they on an isometric line, or did you have to go off the beaten path? Right? So those are called non-isometric lines. They're not on the isometric axes. Okay. Does this circle look like a circle? I think I asked third hour this and they argued with me. Does that look like a true circle? Can I make this with a compass?
Yeah.
I mean, I could. Could I make it just by putting the compass down and spin it into a circle? No. What does it look like to you guys? Huh? Look, a cylinder? Okay, but it doesn't look like a true circle. What does it look like? An oval, right? It looks like a circle that you kind of grab the ends and kind of stretch it out. Okay? Alright, so we're not gonna be overly concerned with this right now. There's a specific way you can cheat to draw these, but that's not very good. I need some practice on that. The last thing you could do is go back and darken this in, and it'll help you now that you have it kind of framed in. You can make it more parallel too. Isometric or oblique? Isometric. Why? There's no right angles. Why else? How else do you remember that this is isometric? What are some of the ways you guys use? What about depth? Huh? What are some of the ways? Am I looking at this thing straight on like a true face, flat face? No. I'm looking at it from the angle or from the corner, right? Oh, that's bad. That's bad. Give myself a C+ on this oval. Alright, so that's the isometric version of this thing. Now, let's do the oblique on the back side, but I'm going to go a lot faster on the oblique. Because I think once you understand keeping lines parallel and what axis you're drawing on, it becomes a little easier. So if you have blank paper, you can draw it on the blank paper. If you have the isometric graph paper, flip it over real quick. Okay. You see the blue part? Okay. Imagine you're standing on the front side of this thing. What shape does that look like? What shape will it look like? Remember what we talked about with this one. What? An L on its back. You see it? That's why I was stressing this ramp. You're not going to be able to see it because you can't see depth from the front view. Okay? What did you guys tell me about an oblique drawing? You're looking at it from what? Straight on. Okay? Straight on. I'm going to flip it over so I have more room. Okay? So, draw the L on its back. Now because it's straight on now, these lines are Tell me what these lines are here. What direction are they? Vertical and horizontal. Which makes what kind of line or what kind of angle there? A right angle. What did you say? A good one? A 90, perpendicular, all the above. So the only thing now when we're drawing these is an oblique drawing. The only difference is once we have this done, once we look at it from the front of it or straight on, now our depth lines can go back at the same angle that these went. Okay? But our width lines have to be what? Are the width lines at an angle? Well, trick question, because a 90 or a 0 is still an angle, but they have to be parallel to these horizontal lines. Okay? So we just have to start going like this. 30 degrees, 30 degrees.
30 degrees.
Okay? But when I draw this line here, this has to be parallel to what line that I already have drawn? It has to be parallel to what? This horizontal line, right? So it's not at an angle, it just goes parallel like this. See the difference? The depth is the difference. The depth is horizontal. I'm sorry, I screwed that up. The width is horizontal, right? The width lines are no longer at an angle. See how the width lines here are at an angle? In an isometric? In an oblique, they are horizontal. I just have to keep my depth lines parallel to my depth lines. Horizontal. Collinear, remember. Use your construction lines if you need to make them collinear. Oops, I'm getting off the beaten path again. Horizontal. Stay horizontal. Parallel. There's really not that much difference when you're drawing these isometrics versus oblique. Okay?